Yeah, so hi everyone, my name is Javed. I'm a second year undergrad at IIT Kharagpur, pursuing chemical engineering, and this is regarding my task given to me in TSF as a TSF intern. So, so we import pandas module, numpy module, matplot module, and from matplot module we import PLT library, which is used for data plotting and visualization. This is nothing but an RC parameter. You can read more about this on the internet. So first we read the data from the link which was given in the document. Using pandas read CSV function, comma separated file functions, and this is a comma separated file. If you just open this in the browser, this is a comma separated file. After the data is imported, we print data is imported successfully. Now I've imported all the data. In the example, it was given that you should only include the first 10 values which are given, but I have imported all of them. So we plot our data points on 2D graph to eyeball our data set and see if we can manually find any relationship between the data. We can create the plot with the following script. Now this is just used for plotting. This is basic plotting function from matplotlib. This is the title, hours versus percentage. This is on the x-axis hours studied, and on the y-axis we have percentage score. So we obtain this data using the linear regression. Not using the linear regression, but using the data points which are given. On this, we'll compute the linear regression training and tests. From the graph above, we can clearly see that there is a positive linear relationship between the number of hours studied and the percentage of score. Now, the next step is to divide the data into attributes. So this is just used for dividing the data. This is just like, is a primarily integer position based on 0 to. So this is basically reading the array specified from index I to index j. This is a Python function. Now we use the scikit-learn module. From that we import the train test split library. So as the name suggests, this is used for splitting the data for one set for training and then another set for testing. This is nothing but splitting the data. Now we train our algorithm. So as I said, we have split our data into training and testing sets, and now it's finally the time to train our algorithm. So using the linear regression library from scikit-learn module, and its subpart linear module, this is nothing but linear regression function, which is defined in the scikit-learn module. Scikit-learn module, yeah, linear regression library of scikit-learn module. So we just fit our data into it. Now training is complete. After the training is complete, we now need to plot the data. So this is defined according to that. Now this is the line which is of the mean data, or you can say the linear regression line. So if, for example, given what is the value given, we have to predict it on 9.25 hours, right? So 9.25 will be somewhere here, 80 plus or 90 plus, most probably 90 plus. But yeah, we'll see. So after making the predictions, now we have trained the algorithm. It's time to make some predictions. Now this is printing the x value, and corresponding to that the y values are uh, predicted according to the linear regression line. So these are the values. This is basically 2D array or 2D lists. In Python we call it data frame. This is the data frame. So we use the pandas library data frame, pandas module data frame function, which is used for plotting the actual versus predicted data. This is the table which comes out of it. Now we can also test with our own data, which we have done here. So we have taken the hours arbitrarily as 9.25. This is basically just predicting based on the data that we have taken. This is a 2D array, or this is a 2D list or array with whatever you want to say. Therefore, I've written it like this. Otherwise, it would have been inside a single parenthesis instead of two. So we just predict our data. Now evaluating the model. The final step is to evaluate the performance of algorithm. This step is particularly important to compare how well different algorithms perform on a particular data set. For simplicity here, we have chosen the mean square error. There are many such metrics. So the algorithm which we have used is mean square error. So you can read about it. It's pretty easy. Basic math. From scikit-learn, we import the metrics library. Now, according to that, we use the mean absolute error function in metrics library, whatever you want to say, to print the mean absolute error, which is 4.183, whatever is available here. Thanks.